Okay, for our session today, we will be having geometric sequences. Now, let's have the following definitions first before having geometric sequences. You already know what a sequence is. It is a set of numbers called terms arranged in some particular order. An arithmetic sequence is a sequence with the difference between two consecutive numbers or terms is a constant. The difference is called the common difference, denoted by the letter D. And this will be the definition of geometric sequence. It is a sequence with a common ratio R. The ratio of successive terms in a geometric sequence is a constant called the common ratio, denoted by the letter R. So to expound this more, let's have this example. So find the next three terms in the geometric sequence. Now, if you will be finding the next terms in a sequence, specifically a geometric sequence, you need to know the common ratio first. And how do you go about solving the common ratio over here? Now, it's very, very simple. Let's list down our sequence again. Our terms, we have 1, 4, 16, and 24. So I will be dividing 4 by 1. So if I'm going to divide 4 by 1, I will be getting 4 for that. So we have 4 over 1 will give me 4. If I'm going to divide 16 by 4, that is 16 divided by 4, I will still get 4. If I'm going to divide 64 by 16, I will still get 4. So therefore, these number 4 over here, this is what you call the common ratio. Okay? Now, let's go back to our sequence and let's verify this one. If I'm going to multiply this by 4, I will be getting the second term. If I'm going to multiply the second term by 4, I will be getting the third term. 16 times 4 will give me 64. So meaning, to get the next three terms, I will simply multiply each term by 4. So I'm going to be starting with the last term in our given, which is the number 64. So the number 64, multiply this by 4. Now, how much do we get when we multiply 64 by 4? That will give us 256. So 256 times 4. So again, 64 times 4 is 256. 256 times 4, that will give us 1024. The same thing, if I'm going to multiply 1024 by 4, I will be getting 4096. So therefore, the next three terms are 256, 1024, and 4096. Now let's have another example. What if you're given like an example like this? Find the next three terms in the geometric sequence. So first step is to find the value of the common ratio, or find the value of R. And how do you do that? You simply divide each term by the one before it. So if I'm going to be doing that over here, so I'll be getting 3 divided by negative 9. Reduce this fraction, common is 3. So 3 divided by 3, that's 1. 9 divided by 3, that's 3. So you're left with negative 1/3. If I'm going to divide this negative 1 by 3, I'll be getting negative 1 over 3, which is the same as our answer a while ago. Now, let's verify. Let's verify. If I'm going to go over here, So what is negative 1 times negative 1/3? That will give us 1/3. The same process, if I'm going to be multiplying 1/3 by negative 1/3, I will be getting 1/9. So the common ratio is simply negative 1/3. Next, here is one hint. Here is one important hint that you should remember. If the given is alternating negative, positive, negative, positive, negative, meaning alternate positive and negative, expect that your R is negative. Again, if alternating ang inyong sign, positive and negative, expect that your common ratio is negative. Now, let's go to step number 2. So, step number 2, we stopped with negative 1/9. So, negative 1/9, I'll multiply this with the common ratio, negative 1/3. So, multiplying the numerators, 1. Multiplying the denominators, 27. Let's continue. 1/27, I'm going to multiply this with 1/3, negative 1/3. So, multiply the numerators, 1. Multiply the denominators, 81. And take note, positive times negative is negative. Next, negative 181 times negative 1/3. So, I'll be getting positive, because negative times negative is positive, 1/243. So therefore, the next three terms are 1/27, negative 1/81, and 1/243. Okay? Now let's move further. What if you're given this? We have 5, negative 10, 20, and negative 40. Again, the first step is to find the value of R. So we have dividing this. This is negative 10 divided by 5. We will get negative 2 for that. If I'm going to divide 20 by negative 10, it's still negative 2. If I'm going to divide negative 40 by 20, it's still negative 2. Now, in solving, you don't need to show all these three. You simply choose whether you will divide any of these two terms. So if I'm going to have this solution, that's totally fine for my common ratio, which is negative 2. You don't need to show all these three. You only need to show just one. Okay? Next, step number 2. Multiply each term by negative 2. So our last term in our given is negative 40. Negative 40 times negative 2 is positive 80. Positive 80 times negative 2 is negative 160. Negative 160 times negative 2, this is 320. So the next three terms are 80, negative 160, and 320. Now, let's have a short, and let's have our next example, by the way. So if I'm going to have this one, so let's get the common ratio again. That's the first step all the time. So we will have, divide this. You will be getting 3/4 for that. Reduce. If I'm going to divide 288 by 384, I will still get 3/4 for that. So if I'm going to be dividing 3 by 4, I'll be getting 0.75. So I can use 3/4, or I can use 0.75. Now, it is easier if you're going to make use of the decimal. Sir, why is it that in our previous example, you did not use a decimal common ratio? It's because the common ratio 1/3, the decimal number there is a repeating non-terminating decimal, meaning it's repeating 333 and it does not end at all. So I will not be using the decimal form for that. Instead, I'll be using the fraction form. But if in case your decimal is terminating, meaning it has an end, Of course, like 0.75, 0.5, 0.2, you can make use of the decimal form. So in this example, I'll make use of 0.75. So I'm going to be having 288 times 0.75. Now, what is 288? 288 times 0.75. It will give me 216. Now, 216, multiply this by 0.75. This will give me 162. 162 times 0.75. This will give me 121.5. So therefore, the next three terms are 216, 162, and 121.5. Okay? Now, let's have a short activity. Find the common ratio of the following. So to get the common ratio, I will be dividing a term and the term before it. So if in case I'm going to use this is 2 divided by 1, which will give me 2. So the common ratio for number 1 is 2. If I'm going to choose 8 divided by 4, it's still, the answer is still 2. So any term and its previous term, it divide, that's the common ratio. If I'm going to have this one, I'm going to be choosing 3 divided by 9. So the common ratio is 3 over 9. Reduce this, 1. Reduce, this is 3. Common is 3. So 1/3. So the common ratio is 1/3. Okay? Let's have example number 3. So we have here, example, I'm going to be choosing 6 divided by 3. 6 divided by 3, that will give us positive 2. So therefore, the common ratio for number 3 is positive 2. Let's have our fourth item. So if I'm going to be choosing this divided by negative 1, that is 2 divided by negative 1, the result is negative 2. Therefore, the common ratio for number 4 is negative 2. Okay? Now, let's have finding the next terms. What if I'm going to be asking you, what is the next term, just one term for each of the following sequences? Now, how did I get 32 here? The common ratio here a while ago was 2. So I'm going to be multiplying 16 by 2 to get 32. So the first step is to get the common ratio first. So we have the common ratio. This is 1 divided by 3. That's 1 over 3. So I'm going to multiply this by 1/3. Therefore, the answer is 1 over 9. Number 3. So I have here 6 divided by 3. That is, it will give me a common ratio of 2. So I'm going to multiply 2 to 48, which will give me 96. Number 4. If I'm going to be having 2 divided by negative 1, the common ratio is negative 2. So times negative 2, that will give us negative 16. Okay, now, let's play guess the sequence. So I would like you to identify whether this is geometric or arithmetic. Let's have example number 1. 3, 8, 13, 18, and 23. Examine them. Is there a common difference? If there is, it's an arithmetic sequence. Is there a common ratio? If there is, then it is a geometric sequence. Okay, this is arithmetic, and the common difference is 5. So take note, the pattern is plus 5. Let's have example number 2. Yes, this is geometric because look at the pattern. The pattern is multiply this by 2. Okay? Let's have number 3. Sir, it's geometric and the pattern is 1/2. And the pattern rather, or the ratio is 1/2. And you have noticed it over here. This is divided by 2. Because when you multiply a number by 1/2, it's simply dividing the number by 2. Okay? Number 4 rather. It's arithmetic and the common ratio is negative 4 because the pattern is subtracting 4. Okay? Number 5. think carefully. Is this arithmetic? Is this geometric? This is neither, because there is no common difference and there is no common ratio at all. If you're gonna examine the numbers there, no constant number is being added, no constant number is being multiplied. Number 6, this is also neither, because it does not have a common difference nor a common ratio. Okay, so that will be the difference between arithmetic and geometric. So look at this one. When I say arithmetic, it's simply adding or subtracting a number. When I say geometric, it's either you multiply a number or divide a number. Let's go to our geometric sequence formula this time. So a sub n is the nth term, a sub 1 is the first term, r is the common ratio, and n is the term number. Now, let's proceed to our first example using the geometric sequence formula. So, our first problem is this. What is the general rule of the sequence? When you are asked of the general rule, it's simply you are looking for the nth term formula. The nth term formula. Or, in some books, they call this the explicit formula. So to get the explicit formula of this geometric sequence, I will be using the geometric sequence formula. Thus, a sub n, a sub 1, r raised to n minus 1. You have noticed that this is the first term. Substitute it over here. So this becomes a sub n is equal to 4. Now, what is the common ratio? If I'm going to divide 16 by 8, 16 over 8, that will give us 2, which is our common ratio. Therefore, I'm going to make r 2. And just write n minus 1, just rewrite this. And this will answer our question about what is the explicit formula. Okay? Let's go to our next example. So, what if you're given a first term of a geometric sequence is 500 and the common ratio is 0.2? What is the 7th term of the sequence? Now, let's identify the given first. This is a sub 1, which is the first term. 0.02 is the common ratio, that's r. The 7 here is the value of n. Okay? So, using the formula, I will be substituting 500 over the first term and 2 over r to get the explicit formula. So this becomes 500, which is our first term, r, which is 0.2. Now, we are solving for the nth term. So we will be substituting 7 over n. So this becomes, substitute 7 for n. There you go. N now becomes 7. Then you simplify the exponent. Just subtract these two. You will get 6 for that. And then, using your calculator, you start with this. 0.2 raised to 6. And whatever the result is, multiply that to 500 times 500. The result is 0.032. Therefore, the 7th term of the sequence is 0.032. Let's go to our next example. So we have here a geometric sequence. The first term is 5. The common ratio, which is r, that's 2. Find the 6th term. So using our formula, substitute. Explicit formula first. What is the value of the first term? Sir, it is 5. So I'll be using a sub n is equal to 5. Multiply this. What is the common ratio equal to? Sir, it is 2. So substitute 2 there. N minus 1. Now, what is the value of n? Sir, the value of n is 6. So let's solve. Substitute 6 for n. So this becomes a sub 6 This is equal to 5 times 2 raised to 6 minus 1. Now, let us simplify the exponent. A sub 6 equals 5 times 2. This is 5. So using your calculator, 2 raised to 5. Again, you start with this. Then whatever the result there, you multiply that by 5. 32 times 5, you'll be getting 160. Meaning, the sixth term of the sequence is 160. Okay, now let's have our next example. What is the ninth term of the geometric sequence? 2, negative 6, 18, and negative 34. So you have here our formula. Let's substitute. A sub n, the common ratio, the first term, it's 2. The common ratio, you divide. So you have the common ratio is equal to negative 6 over 2. That will give us negative 3. So the ratio is negative 3, then n minus 1. So take note, this is our explicit formula. Now, what is the value of n? Sir, the value of n is 9. So I'm going to substitute 9 for n. 9, this is 2, 3, that's negative, 9 minus 1, which will give us 2 times negative 3 raised to 8. So using your calculator, so what is negative 3 times raised to the exponent 8 equal to? That's 6,561. Multiply that by 2. That's 13,122. So the answer to the question is simply the ninth term of the sequence is 13,122. Now, let's have a very important concept here. If there is a parenthesis there, just like over here, the two are not equal at all. Because if you're going to use your calculator without any parenthesis, negative 2 raised to 12 will give us negative 4,096. But if I'm going to place it inside a parenthesis, it will give me positive 4,096. So determine the difference. If I'm going to be placing a parenthesis, the negative sign is included with the exponent 12. But if there is no parenthesis, it's only the 2 and the negative sign isn't included with the exponent. So that is the difference between having a parenthesis and not having a parenthesis at all. Okay, let's have our last example. But if you're given this one and you're going to be looking for the eighth term, so we are using the formula again. Let's get the explicit formula. So we have here a sub n. The first term is 1,000. 1,000 times the common ratio. So take note, the common ratio is simply, sir, can I use this? Okay, you can use that. 250 divided by 500. We can reduce this to 1/2. Or we can write this as 0.5. So I'm going to be having 0.5 for my common ratio. N minus 1. Sir, can I have the fraction form? Yes, you can. So n, that's 1,000 times 1/2 raised to n minus 1. But in my example here, I'll be using 0.5 in my solution. The value of n is 8. Okay, this is a sub 8. This is equal to 1,000 times 0.5. 8 minus 1, which will give me 1,000 times 0.5 raised to 7. So what is 0.5 raised to 7? Multiply that to 1,000. It will give us 7.8125. So the eighth term is simply 7.8125. And that ends our tutorial about geometric sequences. Till our next video, goodbye.